Alright, welcome back to part 2 of Gradle build scans, and in this particular part we'll be tackling the usage of Gradle build scans. So just as a recap, what is a build scan? It is a representation of data captured as you run your build. So as you run your build, this is where you'll be able to capture all the data contained within your build. And secondly, it's a shareable and centralized record of build that provides insights into what happened and why. So the key parts you need to focus on is that it is shareable and it is a centralized record, so you can just tap into the insights of what happened to your build and why your build behaved in a particular manner. And by applying the build scan plugin into your project, you'll be able to publish build scans. You can do this for free at scans.gradle.com. So in this particular part of the series, we'll be tackling the build scan highlights. And in a nutshell, we'll be going through the different parts of the build scan. And if you can see the screenshot on the right, those are like the different parts of your build scan. So in this series, we'll tackle the summary, the console log. We'll look into the test section as well. We'll dig in deep into performance because this one is pretty detailed, but I'll try to explain it in depth, just the different parts of the performance tab. We also have the timeline and the dependencies. Let's look at how to run a build scan as a recap. So for starters, you can run it as a Gradle task in your command line by just appending the -- scan to whatever task you run in your command line. And secondly, you can add it to your build.gradle file. For starters, just add it to the app module build.gradle file, and you add the build scan closure with its parameters. And if you look at the screenshot on the right, you can see at the top we've added the plugin closure. That's the plugin itself, Gradle build scans, and then there's the Gradle enterprise closure, and within that there's the build scan closure, and you can see the different parameters that we pass in, the terms of service URL right there, then the terms of service agreement, and then you specify if you want to publish it for every build execution by adding the publish always parameter. And with that, let's get into our build scan and understand more about the usage of build scans. All right, so right now we will start by generating our build scan. And as I'd mentioned earlier in the slides, I said that when you run any Gradle task on your terminal, you can append the -- scan to it. But in our case, we won't, because we have already set up our project to always publish build scans for every build execution. And if you look at your project level build.gradle file, you'll see here's the setup for the build scan. So we add the plugin, and then here's the build scan closure, as I explained earlier, and publish always means we will always publish build scans. So let me just run this particular task. This is for assembling our project, and this is for running our unit test. So let me just run that, and at the end, we'll be able to see the particular build scan. All right, so we can see that our build has failed, but we don't know why. So let's dig into the build scan and figure out why exactly this build failed. So I'll just click on this link and it should open the browser. And here we are, we have access to our build scan now. So for starters, we'll start with the summary. So the summary just gives you an overview of your particular build scan. As you can see here, it's showing that we have a task failure. It's showing the number of tasks that were executed, our total build time. And then it's showing the particular test that failed, which is good. The number of projects, the dependencies, and the switches right here. So it just gives you an overview of some of these tabs that are here on the left. So from there, I think we can dive into the console log. All right, so we'll begin with the console log. And what you need to consider about the console log is that it includes the console output produced by the build. So many tools used by the build, such as compilers, often write diagnostic information to the console log. And to view the console log, we'll just click on it right here, and you'll get to view that diagnostic output or diagnostic information that is contained in here. As you can see, it shows that the different tasks that were run, and in our case we had a test task, so you can see the different tests that run, and this is our particular test that failed right here. So as you can see, this is the console output. In a nutshell, it shows you even the failure, and the build that failed, and it tries to also explain what went wrong. So what you'll see here in the console log is what you'll see in your command line when you run a task on your command line. So this is the similar to the output that you'd see on your command line. So one last thing I'd like to share is that the output of the console log is pretty shareable, and it really helps with debugging. So for instance, this is the particular test that failed, and if I wanted to share it with my teammates for them to help me debug it, all I'll do is just hover over it, and there's this link here. So once I click it, you can see it becomes highlighted, and if you check right here on the browser URL, you can see that it highlighted line number 77. So if I share this link with my teammates on Slack or whatever communication tool we use, when they open it on their browser, it'll bring them exactly to this particular test, and they can help me with debugging. So this just shows you how shareable different parts of a build scan are. Alright, so next we'll be looking into tests, and tests are an important part of software development in that tests help you determine whether your code is working as expected, and also if you make any changes to your code, if there are any breaking changes, tests can definitely highlight this for you. So to access the test section of the build scan, you just click here on the left and it'll show you the tests. And the build scan helps visualize the test results, including test durations, logging the output and the outcome. As you can see here, these are the test outcomes, the duration as well. So as you can see, it can show you that some tests failed. And this is the specific test that failed, load tasks error. And if I click in there, it'll show you the reason why it failed. So it was expecting it to be empty, but it seemed to have returned some results, as you can see here. And the beauty is that it can help you narrow down to a specific area where the task seems to be failing. So as you can see right here, you can see that it is in the tasks view model test file around line 122. You can see how useful build scans are when it comes to helping you quickly debug certain errors in your code. So a key benefit of build scans are the various insights they provide into build performance. And one thing you need to keep in mind is many builds provide different functions for different people and will perform differently on different machines. So different companies, different individuals have different specs on their machines, and you'll find that the different builds serve different functions. So that's one thing you need to keep in mind. So having deep performance insights available for every build enables optimizing on all aspects of the build for all users. So whether it's individual developers, whether it's a specific team, or whether a team has build engineers, people who are responsible for the build, it gives them deep performance insights on all the aspects of the builds that they may be interested in. So to access the performance, we just click on the performance tab here, and as you can see, the performance tab is quite detailed as it has other tabs available inside it. So we'll begin with the build tab. So the build tab provides a high-level build time breakdown and memory information. So as you can see here, it just gives you top-level build time information. So it can show you the amount of time that your initialization and configuration took. When you look to the execution, it can give you an overview of that time. And also when it comes to memory information, it can show you the heap memory usage and all the information here. So you can use this information, this build information available to you, to benchmark against some of the recommended benchmark figures that are highlighted by the Gradle team. Next, we'll move to the configuration tab. This tab provides an interactive breakdown of the time spent configuring the projects participating in the build, highlighting the slowest scripts, plugins, and lifecycle callbacks used during the build. So the slowest scripts, plugins, and lifecycle callbacks are typically the best candidates for optimizing in order to make your builds faster. And that's something I'd highlighted earlier on. So you can see your total configuration time, the total tasks, the different scripts, and you can dive deeper into them and just get a bit more information regarding them, just showing the script time and stuff like that. So you can see it starts with the script that took the longest time to the one that took the least time. And once you start diving deeper and you see some figures that seem to be taking long in terms of configuration time, you can dive deeper into them, find out which script in particular, and just try to ensure that you can try and reduce that time to make your builds faster. So as you can see, the build scan gives you a lot of information to really help you optimize your builds. Next, we'll move on to the task execution tab right here. And this particular tab gives you a concise breakdown of the tasks that participated in the build, grouped by outcome. So what it does is it provides a high-level view of task execution and can be used to understand incremental build and build caching coverage for a particular build. In a nutshell, you can see the tasks that were avoided, the tasks that came from cache, and as you can see, those are 0. And that to me communicates that we haven't necessarily set up our cache. And as you can see here, for the tasks that were executed, for tasks that are cacheable, they're 0. Tasks that are non-cacheable, there are a bunch of tasks in here. So it can show you that we haven't necessarily set up our build cache, and we are not yet benefiting from the avoidance savings that caching introduces. And just to add to that, as you can see here, we are not getting anything from the local cache, as you can see, or a remote cache. So it just shows you that we haven't set up caching for this particular project. Next, we'll move on to the network activity tab right here. And in the network activity tab, it lists the network requests made during the build and can be used to identify slow dependency repositories or particular troublesome requests. So this particular network activity tab can help us in debugging in case there are any slow dependency repositories or any troublesome requests. So in our case, as you can see, everything is 0. So I think we haven't particularly set up caching, and that's why the activity in here seems to be returning no results. Next, there's normally a build cache tab, but in this particular example, we haven't set it up. But the build cache tab normally shows up here, and it basically displays the build cache configuration for the build. So whether local cache was used or whether remote cache was used, and it lists the individual build cache operations and how long they took. So this particularly is useful for analyzing the performance of the remote build cache connection and identifying whether a slow connection is having adverse effects on the build time. So in as much as we might use the build cache or a remote build cache, it doesn't always mean that it will be beneficial to us. Sometimes the network connection might be slow, and you might find that it's hurting our build speed more than helping reduce the build speed. So in the build cache tab is where we can dive in and just figure out whether slow connection is having adverse effects on our build cache, and also which particular build artifacts are taking a longer time to download. Regarding the build cache, don't worry about that. We will dive into it in later videos, but just keep a mental note regarding that. The timeline is particularly used to optimize cacheability. And one thing you need to keep in mind is for a task to be cacheable, its implementation must meet certain criteria along with its configuration. So build scans make it easy to see which tasks are cacheable and why those that aren't cacheable are not cacheable. To access the timeline, we'll come to the tab on the left, click on timeline. And once it loads, you'll just see a bunch of different tasks in here, right? So for us to optimize cacheability or to check and inspect certain tasks, we just click on the magnifying glass here, and it gives you different options like the task path, the task type, the outcome. So for instance, if I want to check whether any of these particular tasks are coming, the outcome is from the cache, meaning that they weren't run but we're getting their output from the cache, we can click on this, and as you can see, no tasks are highlighted here, meaning we're not getting any of the benefits of implementing a cache. When we come here to task output cacheability, we can see like the different options that are available. So we can start by clicking on cacheable just to see if there are any tasks that are cacheable. And in our case, we have none. So we can click back here and see, for instance, we say tasks that are not cacheable, but for any reason. So it will display anything. So for instance, we can see here the pre-build task is up to date, but it's not cacheable because the task has no actions. That makes sense. These are some that are not cacheable because the build cache is not enabled. And as I mentioned earlier, we haven't enabled the build cache. So there's some tasks that are not cacheable until we enable the build cache. So I'll just click that. So not cacheable, build cache not enabled. And these are some of the tasks that run again, but because the build cache is not enabled, we are not benefiting from the build speed savings that would be available if we enable the build cache. So you can see here, even our task that failed, we could benefit from the build cache, but it's not yet enabled. So as you can see, the timeline is very important when it comes to optimizing cacheabilities, because it can help you dive in here and just see why certain tasks are not cacheable. It shows you the specific tasks, the reason why they're not cacheable, and you can just try to optimize them just to optimize the cacheability. Finally, we'll look at the Dependencies tab, and this particular tab helps you in understanding your dependencies. One thing you need to keep in mind is that each build scan provides an interactive visualization of every dependency configuration resolved during that build. So you can search for dependencies across projects within the build by name and just different parameters as well. And to see this, we'll just click under Dependencies. And you can see we only have one module, the app module. So we'll just click that. And as you can see, these are the different dependencies that are coming through, whether it's the Android APIs, and you can see where they're coming from. So you can see we're getting this from Bintray, whether it's stuff to do with the capped, we just can click in there and see as well. Stuff to do with the lint checks as well, we can view them in here. So you can see the different dependencies that you have for your project. This is for Jacoco. As you can see here, these are the dependencies. You can see these are the details. And when you click in here, you see the specific dependencies. And it also shows you required by. So there's certain dependencies that are required by others. And it sort of shows you that dependency graph in here. So in a nutshell, we've gone through the highlights of the build scan and how you can use it to debug and just get further information, whether it's to use it to further debug, whether it's to use it to further optimize your cacheability, and just the different benefits that you can derive from using build scans. As I'd mentioned earlier, we can use build scans to help us debug and fix issues with our builds. So as you can see here from the red color, it's showing that our particular build scan has an issue. There seems to be a failure. And once I clicked on console log and went through the logs, I could see that this particular test is what is causing the failure. And since we have a test section, you can click on tests right here. And we can see in specific, it's the load task error test that's failing. Once I click into that and come here, we can see that it's saying that it's in the tasks view model test file that there seems to be an error around line number 122. So if I switch over to my IDE and we search for that particular file, tasks view model test, and open into it, let me just close the sidebar so we can have more space. You can see that under this test, I made a change just to cause it to fail. So if I revert it back and run the task again, as I'd done earlier, the Gradle tasks to assemble and also run the tests, I'll let it run for a bit. And once it's done, I'll share the build scan. All right, you can see the build scan was output. Right now, there are no failures. As you can see, the build is successful. And once I click on it and open it in the browser, you can see that now the particular build seems to be passing and everything looks okay. So there are no failures anymore. If I click in console log real quick, you can see there are no failures anymore. And that's how you can use build scans to help you debug any issues you may be facing with your build. And with that, we've come to the end of this particular video regarding build scans and their usage. I hope you found this useful, and stick around for the next couple of sessions in which we'll be diving deeper into caching. Thank you and see you then.